Welcome to the show, everyone. It's the Crypto Lark, and today I got to sit down with Hamayan from Fetch.ai to discuss their upcoming sale, but also what they're doing and artificial intelligence overall. Hamayan, welcome.
Hi, thank you for inviting me. I appreciate it. Glad to be here.
Absolutely. Absolutely. A pleasure to have you here. Now, just for everyone out in the audience as well, just a few quick notes. This is a sponsored interview, but I've got the right to ask all kinds of fun and interesting questions, so we're going to be doing exactly that. And unfortunately, citizens of the USA are excluded from the sale. So, Hamayan, let's jump into some artificial intelligence questions here. What are some of the biggest benefits that you see of AI?
Well, there's several, but I think the one which I like to focus on is the fact that things will become autonomous. Autonomy in decision making is quite a strong and very powerful benefit of AI. Now, when we talk about autonomy, it's not complete autonomy. It obviously has to deliver against people's will and the stakeholders' will. But what it does is it gets rid of complex integration systems, and it gets rid of the friction in terms of interaction between humans, machines, and machines to machines.
Very, very cool. It's AI, I feel like, is one of these topics that people have a lot of misinformation about. Particularly when it comes down to what they see in the cinema and things like this. But actually, the possible benefits of the technology are certainly far-reaching. Um, why do you think, why are people afraid of AI? Why do people see a future of AI as being something potentially scary?
Uh, I think people, it's the lack of understanding. To be fair, I think what needs to be understood is what is meant by AI, and if you allow me, I can just quickly go through how it should be understood, how I feel would be beneficial to understand it. So, artificial intelligence. If you forget the word artificial at the moment, let's talk about intelligence. What is intelligence? Now, intelligence is a capacity or capability of making decisions. Now, to make these decisions, you need parameters to assess to make the decision. So these parameters, let's just call them predictions. So let's say if you have to decide if you're going to walk out of the house, are you going to take an umbrella or not? That decision, when a human makes that decision, it's based around what can you predict. So the prediction is it going to rain or not? You look outside and you think, okay, it's sunny. It doesn't look like it's going to rain. Look at the weather station. So your prediction is it won't rain. So you won't take the umbrella out with you. So if you look at that basic example, that's an example of effectively intelligence, because intelligence is a decision making process. And if you then talk about artificial intelligence, it's giving software the capability to make such decisions based on inferences and predictions. So that's really what artificial intelligence is. Now, how you build these predictions and what kind of framework you give the software to make that decision, it's still in our control. Now, I understand, yes, we have this, that the software will build its own software and it will become more and more intelligent. And we are quite far away from that general intelligence at the moment. It's not there yet. And I think the advantages of this machine learning and AI are way uh, they outweigh completely what the fears are. And the fears are quite far fetched in the sense that, this machine is going to take over the world. Now, I understand the issues here. If you put one big machine and it kind of collaborates with itself and builds something that ominous, what we are proposing is more a decentralized approach where no one party has a big control. Actually, that's one of the key elements which I really quite believe in, is that this machine learning and AI should be all inclusive. You shouldn't kind of exclude women, uh, black, white, all races, all colors. They have to have a stake and they have to have a role in creating this new phase of intelligence.
Very, very cool. I like the vision, certainly, and I think that decentralization will be a very important part of all systems moving forward, but certainly AI. And I think that a lot of the scary movies have come from like one computer going rogue and destroying humanity or something like that. So, yes, in order to avoid such
Absolutely, yeah.
apocalyptic
Absolutely,
situations.
yeah. And I think there is a lot of this happening in the sense that there are a lot of big corporates which are controlling this space, and Fetch's main objective is to get that out in the open and make machine learning and AI so simple and easy that we as normal people can use it in a day-to-day life all the time, rather than being um, controlled by these big corporates.
Yeah, very cool. Very cool. I mean, certainly the big corporates have a lot to answer for, and the more power we can take back for ourselves to be, our own personal agents, so to speak, and have our own agency, that's really important, without a doubt. I wanted to ask you one more question, kind of general AI stuff, before we jump into a little more of what Fetch is doing. So, what do you see as being the biggest moral dilemma in AI?
I think we touched on it a little bit. It's the inclusiveness of things and people. It's all inclusive. I think the biggest issue we have at the moment is the control on this cool technology, which is machine learning and AI. Now,
Mm-hmm.
it's not fully there, and it's going to be developed a lot more. But I think, in my opinion, the biggest dilemma is that we don't want this to be in the hands of only a few. And the
Mm.
reason why we don't want that is because that will create biases which are not fair to the rest of the society. So if you think about when I say all inclusive, and when I say it has to have that ability to include all people, and the ability to enable them to participate in the creation and utilization of this, whatever you want to call it, this machine learning and AI space, that is quite a key dilemma, which at the moment we do not have a solution to.
It's going to be one of the big questions for society moving forward over the next few years, for sure.
Yeah.
Now, let's jump into Fetch.ai. Can you give us the elevator pitch? What exactly are you guys doing?
It's a decentralized machine learning and AI platform which enables multi-agent systems to be run on it. That's really, in a technical way, that's what it is. And what it means is that we talked about decentralizing AI. So one, it enables you in a decentralized way to develop various machine learning and AI algorithms, which means and actually what that means is it has a marketplace for predictions. So, and why do we need these predictions? Now, if you're a human, if you're a business, if you're a machine, and if you want autonomy and you want to make good and right decisions, you need predictions. Now, these predictions could be what's the weather going to be like, or what the price of a commodity will be doing over the next 20 years, or which object is going to be in demand, or in supply chain, how do you schedule efficiently what the transport is doing? All of these are predictions. And to build those predictions in a decentralized way where everybody can participate, you don't have to be a big corporate with a big deployed AI machine learning team. That's quite a key commercial proposition of Fetch. So that is the first bit. And the second bit is, let's say you build these prediction models, you need to monetize these predictions. How do you sell these predictions, and why do you sell these predictions? So what it enables you to do is, it allows you to build these prediction models without the danger of losing your data. So your data, or any company or corporate's data, stays with them. You build these prediction models which can then be utilized by autonomous agents. Now, we specifically call them autonomous economic agents. So what it means is it enables these agents to exchange economic value. And so it connects people with value to people who want value. Now, these people can be replaced by machines. So although the stakeholders could be humans or machines, it enables them to connect autonomously and exchange value autonomously.
Very, very interesting. The idea of the autonomous economic agents is certainly fascinating, and it makes you realize how many stakeholders are at play in this entire developing ecosystem. So, you guys are using what's called a smart ledger. First off, what is the smart ledger, and then what is a dumb ledger? On the flip side, I
Sure.
suppose.
So if you were to deploy a decentralized system where multiple stakeholders have to, via the autonomous agents, have to make autonomous decisions and carry out these tasks. So the first thing you need is a system whereby when the exchange happens, it's recorded correctly. And it's recorded on a decentralized system. So it's not centralized. Anybody can go in and check it. But more importantly, when you transact with other entities, when these stakeholders transact, the biggest issue is trust. So how do you trust somebody else? So that trust value evolves from the transactions you have completed in the past. So a ledger which one can connect you intelligently with other entities, because if you come in, it's like saying, well, you come in for something, there's a million websites, how do you find these websites, right? So you go on Google and you search, and it intelligently gives you all these sites which you would want to go to see. When you have millions of agents, when they come in the market for a service, how do you find the other agent which has got what you want, or the prediction that you want, and be able to trust it? So that has to come from a framework and a ledger which records it, which enables you to make these autonomous decisions and find these parties without any outside interference. So that's the key of our smart ledger, that it enables you. It has to be scalable because you have a lot of transactions going through. This is not a currency or payment method. This is not just a payment method. It's about an economic exchange, but not the economic exchange alone, but also transaction in terms of finding these agents and intelligently connecting with them. That's what the smartness of the ledger comes, and building this trust value. So if you're transacting with another wallet, which belongs to another autonomous agent, you have to have these trust ratings where you can say, okay, this I can transact with this agent with trust. I feel that it's like a rating system, but it's inherently built within the ledger, and the ledger then also enables you to connect to other agents. Now there are multiple layers within the ledger, but the scalability is also quite an important key. I mean, if you look at Ethereum network, or if you look at quite a lot of the networks at the moment, their transaction speeds are pretty low. And these transaction speeds, without going into too much technical detail from the ledger side, these transactions need to be completed between various parties, and they have to be settled, and the finality has to be achieved. Now, if it takes you several seconds, or 10 seconds, or 20 seconds, autonomous agents are transacting in milliseconds, so they need to make that decision a lot quicker than these ledgers can enable you to do. And not just make the decision, but also transact and exchange value. So all these features need to be part of the ledger, which makes it smart.
So that you guys have are advertising around 10,000 or tens of thousands of transactions per second at near zero cost. That's really cool. How exactly are you achieving that? Again, without going too far into the tech, I mean, how much decentralization are we sacrificing to get such a high throughput of transactions, for example? And
the key feature of the ledger is the resource laying concept. So what it means is that it's kind of a form of sharding, but it's a more intelligent form of sharding. So you have these resource lanes. So for example, if a transaction is happening between London and London and kind of Sydney or something, these transactions are split into these transaction lanes. All the other lanes don't have to be involved in that transaction. So what you do is, rather than settling that the whole ledger at all times has to be complete, you can have them. You can have these resource lanes complete rather than the whole ledger to be complete. What that does is it improves the transaction times quite a lot. And then you have the consensus mechanism, which is quite an interesting one. Now, without going into too much detail, it's a combination of a proof of stake and useful proof of work concept. Now, the proof of stake in itself is quite a fast way of consensus. Which is our first implementation, but it's a little bit more unique than just a simple proof of stake. Without going into too much detail, which there's a couple of papers which are coming out in the next few weeks. But we are also trialing with it another mechanism of useful proof of work, where again this is part of the smartness of the ledger, that when you complete that combined with the proof of stake, which is the core consensus mechanism, it delivers not only a consensus, but it also delivers some useful intelligence, either on the ledger or a more optimization of how we can run the ledger and make it faster. So it's a combination of 3 or 4 quite key innovations, which we have released some of the papers on the ledger, the scalable ledger side. We have released a paper, but the consensus side is coming over the next week or so.
Very, very cool. It's certainly when you start to think about the scale of what you're talking about, you really need this kind of speed for the network. Now, I was just imagining, so this kind of goes back a little bit to what we were talking about just a minute ago, but let's imagine the scenario. So I've got my smart toaster, and it's communicating to the smart refrigerator, and the smart refrigerator says, "Hey toaster, we're running out of bagels here." And the toaster says, "Okay, well, I want to order some more bagels from the shop." Because the shop is a trusted agent, it can do that, so they can have that little transaction. Now, I would imagine those kind of decision-making processes, they're fairly benign when it comes down to it. But what about, I don't know, tougher situations in terms of the machine's actually deciding the answer for something, right? What about, for example, what kind of bagels they're going to order for me? Maybe they think I'm getting a bit overweight and they want to order healthier bagels for me. Will they start making those kind of decisions? Or what if, I don't know, somebody breaks into the kitchen? Will the toaster call the police, or will they say, "Oh, that's just the repairman"?
I think there's quite a lot of questions, and as interesting as they are, I think let's take them step by step, right? So although these are very kind of benign decisions, but what the frustration comes is that when your toaster doesn't know who you are, and you've lived with that toaster for years, but the toaster doesn't know who you are.
That's true.
So that's one thing which that's what we are trying to build, so that you can actually bring context to the devices. Now, if you look at humans, we don't exist in these verticals. So it's not that, just because I'm driving a car, I'm an automotive sector. That's it. For example, your travel dimension of a human would be affected by the family dimension, would be affected by the educational dimension. So we are a collection of dimensions. What happens at the moment, and this is how we have evolved, and this is the limitations of technology. We at the moment operate in verticals. Now, these verticals are all interlinked, but there is nothing here which links them. And the whole idea of building these prediction models, which we are talking about here, is to not only just build prediction models in verticals, but also enable the whole space to find these relations with other dimensions. So your travel dimension and your food dimension and your health dimension are all interlinked, because the food you eat, either when you're on travel or not, or at home, depends on your health. Mm-hmm. So you can't completely separate them out. Now, if you are eating, or let's say your health agent is communicating with your home agent. Now, you have to allow those agents, and you have to give them the autonomy you want. And it's like, initially it will be very much like a sliding scale on a website where you can actually go in, slide the scale, and say my autonomy level is 0 or 10% or 20%, and then you see what kind of decisions come out of it. We as a human race need to get used to this kind of thing, because what it would do is it will bring efficiency to our life. There's so much data, there's so much electronics, and there is so many different things we are getting used to, that a little bit of frictionless autonomy is probably not a bad thing. And that's what it needs to be enabled. So for just to give you an example, travel, right? If I wanted to come to New Zealand, or I travel to US quite a bit, it's a nightmare. Either I have a travel agent who I pick up the phone and I say, look, I need to be in San Fran on this date, just sort the whole thing out. And the person goes out and books my taxi, books my train, books my flight, books my hotel, all of that. I can't do that on the website. We had this excitement about website where we could just go in and do all these things ourselves, but that is kind of starting to wear off a bit, because just to find all these things and
takes
then to
a long
connect
time.
It's becoming more and more difficult. So now but on top of that, if you have a good travel agent, that travel agent knows your context. It knows you. He or she knows you. So they can book it according to your preferences. So if you enable your autonomous travel agent to do the same, what's the harm here? It's only making your life more easy. Now, and the other reason is that you can now order a car, which is an Uber. But why do you need an Uber? Because Uber is a platform which connects the customer to the supplier of the service, which is the car. And all it is it's a middle intermediary who connects these two things together in a very organized fashion. Now, what we're proposing is on the Fetch network, these two agents can speak to each other. Because they can find each other, they can very flexibly connect and arrange the service and do the economic exchange. So this is where this whole thing will evolve quite nicely, is that if you give them autonomy and if you give them the ability to connect to other agents, the friction in this whole thing will disappear. Rather than, it's not about allowing them to take over your life. So we're not saying that the toaster is going to start making decisions which you don't want it to make. It's
Toaster, who bought this car?
It makes it more convenient for you that you already have the bagel in the cupboard, which you actually need, without telling it too many times, or forgetting it when you wake up in the morning.
That's right.
So right. I think it's that bringing that threshold of friction down by giving these agents autonomy.
Nice. Now, the Fetch token, what role is that actually going to play in the ecosystem? Is it basically just used as a transactional, oil, so to speak, between different agents?
Well, that's quite a key. That's a key point here. Now, if you think about how this whole ecosystem is going to run, this ecosystem will run. Yes, there will be an economic exchange. So one party will pay the other party. Now, that is less important for us because, as much as we believe crypto is really quite an important part now, hopefully, of the economy in the coming years, that is quite, we're agnostic on that because, that is the final outward transactions are not really the key here. What is more important is that if these agents are going to transact with each other to find services, to find predictions, because they can't make their decisions without predictions. Somebody has to provide them these models and predictions, or even the model itself has to be able to sell the predictions to the agent. That is a very, very fast transaction because you're not going to wait for, let's say, half an hour to make a decision if you should walk out of the door with an umbrella or without. So those transactions they're fast, so they have to be on this distributed kind of ledger, and they are small in value. So the fiat currency doesn't apply. So they have to be tokenized to be able to run that kind of economy. So whereas quite a lot of the crypto projects are based on these currency exchanges and the value in the whole value exchange, we actually do require it because one, you need to reward the people who build these models and build these prediction models and offer the predictions in the market. You have to then, there is a search and discovery service. So it's like the Google of autonomous agents. So, if there's huge amounts of agents, how do you advertise your agent, for example? How do you, but these are small transactions. These are not big transactions. And they have to be done instantly. So the fiat currency doesn't work. And, the crypto in the old form of crypto doesn't work because if you have settlement times or finality times of 10 seconds, that doesn't really work. So it has to be immediate. So to answer your question kind of one way is we need the token for these autonomous agents to make decisions. That's one of the key features of it.
Very, very cool. And you're absolutely right about this, the time that it takes to do things. Because if you look at the regular interface for most applications people use that are non-blockchain based applications, things happen like that in general, assuming your internet speed's fast enough and your computer processor's fast enough. And people are used to that kind of experience. So if you say, hey, we're going to use blockchain because it's better, and then they get on, they're like, I'm still waiting. Why is this taking so long? It's not better then. It isn't. And we can talk about decentralization and the ideas behind that, but blockchain can be better. Blockchain will be better. It's a question of making it better, I suppose. Now, in terms of your project overall, what kind of progress have you made so far, and when will we see a fully operational Fetch network?
So we have a test network which is running at the moment, and we released the code on that. This is now the scalable ledger code. Now the full test network will be probably released early next year. So you can actually, at the moment, you can kind of test it, and there's I think probably 250 or 230 nodes running at the moment. We're benchmarking the transaction speeds. We have some rough numbers, but which you've already seen. But we think it's going to be way better than that. So I think there's going to be huge improvements coming. We have just to mention that these autonomous agents, when they start negotiating with each other, they need to have a negotiation framework and a language where they know how to offer and how to accept and how to negotiate or bid up or down. So that kind of negotiation framework is now in place. So we have agents running. We have I don't know if you have seen it, but we have a maze demo where we have run a whole set of agents which solve the maze problem and do that kind of on the just singularly or collaboratively. So that is running completely on our Fetch network. So these agents exchange economic transactions and values and sell knowledge to each other and transact. So that's all working. I mean, there is a demo which I can send you. You can have a look at that. So that's all running. And what we are now looking to implement is the same kind of maze concept into the traffic. Because if you look at how the traffic should work, is that all these cars should be communicating with each other. They should be all agents, and they should be guiding each other how to reduce congestion, not just kind of reactively, but actively. So before the congestion is created, it's already reduced. Because if these agents can communicate with each other and kind of exchange economic value and information, they could avoid congestions anyway. So that's still in trial phase. The main net is going to be available late next year. But we are kind of we got some pretty interesting partnerships with automotive sector at the moment. We have a very, very interesting partnership to build these health agents,
Mm-hmm.
which, so for example, if you're in New Zealand and you come to the UK, and if you have an emergency, medical emergency, how do you kind of communicate anything to anybody?
You
So
just don't
so
get
what we
hurt. It's the best method really because it's so painful to try and work through that process of insurance and a foreign health provider and all these different things. It's a nightmare for anyone who's ever had to deal
listen,
with such a
but
situation.
it won't be soon. It won't be, because what we're giving you is a health agent which actually knows exactly who you are, where's your insurance details, and all of that. It doesn't go into the network. It sits with you. The only thing is that the agent knows exactly how to communicate to who with trust. So you enable them. It can learn from your medical history. It can actually make, in the case of emergency, can make people aware of what should and shouldn't be done. And if you need the details, it can securely pass you the details. So that would be a huge benefit to the healthcare sector. So we're working on that, and we're also unfortunately I can't tell you the name of the chain, but we're working with 700 kind of hotel rooms, and giving each room a autonomous agent to then
Mm.
kind of look after itself. So we're trialing that. What it means is that you don't need these complex booking platforms whereby how do you book a hotel room, and even that. But also when you enter the hotel room, it already kind of communicates with your agent to give it context. So it already knows which kind of bagel you like, for example.
There you go.
So
And it
yeah,
tells
and the
it
lighting, the
tells your
mood,
toaster
and
back at home like he's eating bagels somewhere else. Your toaster's waiting for you. I heard what you did. No,
so yeah, that's the kind of projects we are doing at the moment. I mean, we have a couple of another project running in the energy space. So we're looking at virtual grids, which means that your home could, or an office building could become autonomously controlled, and instead of generating, it's like a virtual generation effectively, whereby if you need more energy supply and you can save some energy supply, then you can supply to the grid. So we're working some pretty cool stuff there.
those are all some of the biggest, the most exciting industries. That's really awesome, actually. We have, the medical field, we have renewable energy, we have travel, and the automotive industry. And I actually wanted to expand a little bit on that. How do you see AI and the automotive industry coming together?
I think it's a step-by-step process, right? Now, if you look at, I mean, I was watching the other day, and it was quite interesting. BBC was showing a video here where a Tesla. There are two cars, and the Tesla is in a auto steer, auto self-drive kind of semi-self-drive mode, and a dummy car comes in and out very quickly, and Tesla hits the car in front of it. Now, um, and this it's quite a simple problem to solve, but it's still putting life at risk. Now these autonomous cars and machine learning and AI techniques are improving it, but what is not here is that if that Tesla knew already that the car in front has another car in front, which is where the autonomous agents come in,
Mm-hmm.
without actually seeing that car, it would have already known that that car is braking and it needs to stop. So, so the risk element, which we see quite a lot of at the moment in self-drive cars, whereby who should it kill, and should it turn left or should it turn right, and which car should it hit, why, and all of that. Uh, I think there is a more of a fundamental problem which needs to be resolved before we get to that question. Is the car, the Tesla or any self-drive car at the moment just sees what's surrounding it. If you give it more knowledge of what it can't see, or give it a sixth sense so that it can actually know what is happening in front of it, what's happening behind it, and all that information is well connected, the amount of machine learning and AI and the benefit of that is a lot more than just what you can actually see and learn from just one car. So it's not about can we improve machine learning techniques? And that demo which I mentioned to you about the maze would be quite an example for you to see. It's not about just how much we can learn on its own in its own isolation. It's when you connect these things together, the value you're going to extract from
Mm-hmm.
machine learning and AI is humongous. It's exactly the same as the colony of ants working together or colony of bees working together. In itself, the intelligence is very limited. If you isolate each and every one of them, there's not much intelligence. But when you put them together, suddenly they make decisions which we're still amazed why and how. So that's exactly the same thing we need to do before we start getting too carried away with this. This whole thing is going to take over the world.
Very cool. Now, I want to talk for a moment about your team. So, can you tell us a little bit about the skills that your team has that's going to make all of this a success? I mean, I know you guys have been working already on developing the different technology and getting these cool partnerships together. But what do you have on the team that is going to make you a success above the other AI projects?
Well, this morning we had 43 members of our team, which were actually based in Cambridge. We also have a couple of other teams, which one is in Austria, one is in India, one is in Pakistan. They're also developers. But the core team, which is the 43 people, I think probably around 7 or 8 of them are kind of blockchain. I say blockchain, but let's that's a generalization. It's a decentralized ledger technology coders. So 7 or 8 of them are just working on bringing this scalable ledger to the market. We have four economists working in our team because you have to get the incentive structure right.
Mm-hmm.
We have around 13 or 14 machine learning PhDs which are working in our team, which are developing techniques where how the agents are going to be intelligent, what neural networks needs to, what is the structure of the neural nets we need to build, how does this whole system then extract information for the benefit of all, how do you then combine all of this to incentivize everybody. So that's kind of the core of our team. Then we have some commercial, 2 or 3 commercial people who are just working with our partners to try and find use cases which actually are deployable here. And actually we're kind of really finding it in every single sector we touch. There's so much. There is a pain point of integration. So there's a couple of systems integration engineers we have. We're looking at, if you look at complex systems from top down, they're quite difficult. And the more stakeholders you put in, the more complex systems you kind of try and integrate, the worse it gets. But we have an easy solution. If you make the agents, just like we talked about the ants and the bees, if you make them and give them some level of intelligence and let them interact with each other to find the most optimal solutions, that's quite a key part we're looking at. So there's a few PhD and researchers which are working on building this multi-agent systems and how these multi-agent systems will evolve. So that's really the core of our team, and we're very technology focused. And this is not a small project, and it's a very ambitious project. And whereas we are ambitious, we are also looking at practical applications. So we are building something for today, and then we are without losing the sight of tomorrow. So we're trying to build something quite dramatic, but we know that it has to apply today as well.
Very, very cool. I think that's a great point to end it on. Now, for everyone out there in the audience, there will be a link down below to the Fetch.ai website. We'll also provide a link to that maze demo that Hamayam was talking about, so you guys can check that out as well. Thank you so much for coming to talk to us about AI today and about Fetch.ai. It's been really interesting.
Thank you very much. And I would like to invite any developers who are listening and watching. I'd like to invite them to kind of express some interest, and hopefully we can get them involved. We really have some really cool projects at the moment, so we're really looking for developers to kind of come and join us and start building.
For sure. And again, there will be a link to the website down below. So if you are a developer, make sure you reach out and get in touch with them.
Perfect. Thank you.
Thank you.